Thank you so much for coming, and happy New York Tech Week. So excited so many of you are able to join today. Really looking forward to a delicious lunch, which will be served soon, and an awesome panel with our amazing panelists, who we'll get to in a second. So my name is Sierra Applebaum. I'm a senior marketing manager at Software Improvement Group, or SIG. And before we got started, just wanted to give you a little bit of background on SIG and who we are. So Software Improvement Group is an independent global authority on software quality and technical debt that has been around for over 24 years. So we help businesses and technical leaders and also investors to provide insights into risks, as well as recommendations on software quality, security, resiliency. So with that note, I'm going to introduce our moderator for today, Jasper Gertz over here. Jasper is the Managing Director of Software Improvement Group Americas, and has been in the IT space for over 17 years now. He's also led software projects, over 300 software projects at large enterprises, Fortune 500 companies, including JP Morgan Chase, as well as Thomas H. Lee, and many, many more. And so with that, I'll let Jasper take it away.
Thank you so much for the introduction. Glad to have you here. We're going to talk about technical debt today. But before we do, let me introduce our wonderful panel here. So on my left, Prithvi, Rajasekaran. Very good. Fantastic. You are a seasoned software engineer, as well as the chapter lead of the GenAI Collective here in New York. Pretty large, all up in the West Coast. And Prithvi is basically setting it up here. It's a wonderful organization. So he has led and developed a lot of software in his career. It started business to business in C3.ai, and he's now at NerdWallet. So we're definitely going to talk about your experience with AI, but thanks a lot for joining the stage. And left from Prithvi is Vijay Amiralas. He is a principal solutions architect at AWS. So he has over 20 years of experience in building software, but also assessing software through many different senior roles. So he's very anxious to help customers and people improve architecture software quality. And your latest and greatest topic is developer efficiency and experience. Also a topic definitely we'll discuss today. And we have on the Zoom over there, and hopefully Hakan, you can hear as well, we have Hakan Erdogmus, Professor Dr. Hakan Erdogmus to be complete, a teaching professor at the Carnegie Mellon University. So he teaches all kinds of classes, among which is software quality, software economics, and the topic of today as well, technical debt is part of his teachings. Let's switch to technical debt. Who's dealing with technical debt from a business perspective on a day-to-day basis? Okay, and who's dealing with technical debt in code on a day-to-day basis? All right, so we got engineers, we got architects here. Maybe a different type of question. A statement then. Technical debt is an inherently bad thing. Who agrees? It's a good thing. All right, I guess it's not. All right. How does voting? All right, last question for us to get to know you a little bit better. Now that GenAI has joined the scene, is technical debt a thing of the past soon? No? All right, okay. All right, so panelists, over to you. I'd like to kind of get started with a definition, and who better to give us a definition than Hakan, who talks about this, of course, a lot with his students. So Hakan, in your research and teaching experience, can you help us define, give a good, maybe a more classical definition of what technical debt means, and explain how software quality and interest factor into that definition?
Sure. So, in essence, technical debt is incomplete or improper development or engineering work with compounding implications, and those compounding implications eventually trigger future rework. So that's the idea. It's typically related to or associated with poor software quality, such as cuts taken, maybe insufficient testing, or unfixed bugs. It can also be related to poor architectural and design choices. An example would be an inflexible architecture that hinders future extensions, or it can be excessive code duplication that makes maintenance expensive. So that is kind of the classical definition as introduced by Ward Cunningham many years ago, and also picked up by others like Stephen McConnell, and then expanded upon that.
What are common causes for technical debt?
So the classical basically definition is really software quality. It's so mostly quality shortcuts taken. Okay? Skipping a quality step in the development process may be an example of that. Doing insufficient upfront work, maybe skipping requirements allowances, maybe another example. Making poor architectural choices to be able to get there quicker so that you can catch a market window. Maybe another example, it takes all sorts of different forms. And some of the underlying decisions can be related to, is associated directly with technical decisions. Others have more also managerial and executive implications. But this is kind of the classical scope of it. Recently, it has also been expanded to kind of the neighboring fields, and I think maybe Vidya is going to talk about that at some point. Yeah.
Thanks, Hakan. But so technical debt is a definition that's been around there for a long time. But Prithvi, in your day-to-day, you encounter it often. Maybe you can help us get a little bit of an understanding of what happens in the mind or in the workflow of a software engineering when you need to deal with technical debt.
I think, can folks hear me in the back, by the way? I think that with technical debt, whenever you encounter it, it's kind of like, sometimes it can be like stepping on a landmine, where it's like, okay, do I want to go for the refactor right now? Do we want to kind of get this feature across and then deal with it later? It presents kind of a sort of trade-off matrix in your head that you have to start thinking about. It can be a little bit frustrating when you're like, oh man, I know that there's a clear path to executing this if I didn't have to go through this particular roadblock, but that being there and that being present, what's the right way to go about this? So it leads to a little bit of a confusion, a lot more cognitive processing about the right way to go forward, and then even some frustration for the developer in some cases, depending on how bad that technical debt is.
Right. And so in your example or in your work, what strategies then do you apply then to deal with that, I guess, frustration that you see when you encounter the technical debt? Absolutely.
So I think in the ideal case, of course, we kind of do a little bit of a quick analysis in my head of can I just deal with it in the moment? If it's small enough, then ideally I can put up a pull request where I solve the issue and get the feature done at the same time. In most cases, of course, it's going to be a sort of a larger problem, or maybe even an architectural problem or a system level problem. In that case, that might require a discussion with stakeholders or other teams to say, hey, like I've identified this is an issue. This is going to have these implications for us kind of in the medium to long term. Do we want to handle that right now, or is that something that we want to prioritize for later? And then usually it's discussing with our technical and non-technical stakeholders about the best way forward.
And there's a point in time, thank you, Prithvi, where Vijay, you come in, right? So as a principal architect at AWS, you help your customers modernize systems. So I guess modernization, that happens when the technical debt becomes too large to handle. So maybe you can, from your perspective, give us some insights on signs that you see on when you believe that actually refactoring doesn't work anymore.
Yeah, that's a pretty important. Can everyone hear me as well? It's a pretty important aspect, especially working with customers on understanding when do you hit the point that a refactor is not enough and you need to overhaul the system or you need to modernize, build something. And there is no one size, in my experience and working with customers, there is no one size fits all, but there are some key indicators. I'll I'll break it down into three areas. One is usually the business indicators, and then there's security, and then there's the cost of maintenance. So the first in business, in terms of business impact, you have to see, does your software systems or landscape of systems, does that negatively impact business goals? You could look at things like time to market. Are your developers, like you're saying, are your developers having a hard time working on a very complex code base? Are they looking at lots of technical debt in terms of even documentation, lack of documentation, or architectural issues, or even infrastructure issues? And is that impacting them in terms of putting out features to the market? The second part of that is looking at it from the perspective of when from overall, when I look at it from, there are other things that you can look at. Is I think there's been some studies that have been shown that if your page doesn't load, there's a delay in 1 second, you actually lose your customer conversion by 7%. And IBM did the study just in 2023. So there's very specific indicators that you can see that, okay, this is actually impacting, customer satisfaction or churn. And then the third part of that is looking at it from overall perspective of, okay, what is the bottom line here? Are they able to push features out? Am I able to scale my business? And is that being slowed down? So that's like a bottom line impact to the revenue. So the second part is security, and that's quite obvious, I think, in terms of both compliance and just privacy and data breach. I think there was another study that I forget, it was like on average, they found that any data breaches costs customers 4.5 million for large enterprises, just through just that one. So you can tie technical debt to around security, specific to your bottom line. And then the last is the cost of maintenance. When you start seeing your cost of maintaining the system outweighs the value that it's providing. And that comes in terms of legacy systems and where your developers are frustrated, they're not able to use you. You're going to have a hard time finding talent. Even if you're using a very old system like COBOL, and there's going to be churn. So that impacts developer experience, developer productivity. So all of those things are sort of some key indicators that have been proven that you can use to do an assessment to say, okay, here, I think we need to start to rehaul this, and refactoring isn't going to work anymore. Yeah.
Right. Yeah, thank you. And you just mentioned value. And of course, the title of this whole discussion is how can we boost value by managing technical debt in the right way? And what Hakan just described was a clear but classic interpretation, I guess, of the definition of what technical debt is. But to the panel then, I'd like to ask the question, how did it expand? So you mentioned a few things now. So that's I guess the first part of the question. And the second one is, how can we actually determine the size of it? In person years, dollars? How do we do this? Would like to take it?
I would say
I can take it if.
Yeah, Hakan?
Yeah, sure. So, I mean, the first thing about technical debt is that it is inspired by the financial metaphor. The metaphor is not just superficial. It's actually quite accurate in many circumstances. So we need to kind of understand that. Except maybe in certain circumstances, like, unlike financial debt, technical debt vanishes when the project terminates. In other situations, it pretty much holds quite accurately. So incomplete or improper engineering work requires extra effort to complete or fix. So that is the premise. So that extra effort is basically defined as the principle. But the principle also has compounding effects. Paying it back or performing kind of other engineering or development work may become increasingly more difficult over time, as long as that original debt remains in place. So that extra effort represents the interest. So having defined that, then how do we quantify technical debt? In effort or currency terms is the simplest answer. Unfinished work equals effort delayed or labor delayed, if you want. And if we can express that, estimate that, then we can easily also represent it in dollar terms. For example, I don't know, if we saved 1 person week by skipping functional testing to get the product ready for the next trade show, say, our TD principle is 1 person week. And if we know the average salary of a test engineer, that it is about, maybe say it's 40K weekly, then it would be about 40K in currency terms. So this is the principle. But if this decision results in a 10% productivity hit, in adding new functionality because we keep breaking the system because we don't have, regression tests to rely on. And then if we kind of factor in the monthly salary of an engineer around 160K, and the monthly interest on the principal for a 4-person dev team will be 64 until the principal is paid back. Just realizing that is important because then you kind of look at the ongoing cost of delaying that decision. And then once you do that, you can pit the expected ongoing cost against the action to pay back the technical debt right now. And then that decision is basically a bottom line decision. It becomes a financial decision. So the reasoning, the metaphor itself allows us to evaluate in bottom line terms the cost of foregoing or delaying proper engineering practices against the benefits of performing them in a timely manner. If we can do that, we can also actually prioritize, especially the big ticket TD items according to their cost benefit trade-offs and according to the estimated net value of paying back the debt now. So this is how we can basically kind of reduce it to bottom line terms.
Yeah, and I can, sorry, go ahead.
Yeah, cool.
I can add to that too. There's actually studies that have shown, I'm not sure how many people here are familiar with the DORA's DevOps data, the report, right? So they've shown over years, since like 2018, that in 50% of organizations, large organizations, developers are only working 30 to 40% of their time on feature development, so that you can translate that directly to the bottom line. And there was a recent study by software.com that they interviewed or did survey of 250,000 developers worldwide. And they found that, this was shocking to me, that on average, a developer spends 52 minutes a day on actual coding. And the rest of it is on not technical debt, but it's on maintenance work, on research, on design, and all those other areas. So when you think about it, when you really think about that, over a span of a week, a single developer is spending less than 5 hours on just the coding aspect. So there are ways, and when you have these large scale studies, there are ways to quantify that in terms of developer productivity. How does that tie to feature development and all the other business goals that I mentioned? Yeah.
Absolutely. And just adding on to that as well, I think one valuable way that I try to think about software development and then where technical debt comes into that as well, sort of like an ROI calculation. So in that calculation, there's a numerator and a denominator. That numerator is sort of the market opportunity that you're chasing after by launching this feature, launching this product. And the denominator, since it's a software, is your cost, which in this case is just the time or the expenditure that it takes to actually develop the feature. Now, if it's going to take you 3 times longer than it should to develop that feature because you have so much technical debt, then that has a lot of follow-on implications for your business. It makes the ROI 1/3 based on that simple calculation. You could also miss the market opportunity, so on and so forth.
I was going to ask him, how many hours a day do you spend coding? Do these stats make sense to you?
Yeah, 52 minutes is a little low for sure. But I could see it at really large companies, especially talking to friends and stuff.
Yeah.
It sounds like there's a lot of, drudgery, for lack of a better term.
Yeah.
And yeah, if there was more effort paid to paying down technical debt and even like organizational, architectural debt,
Exactly.
hopefully that number would go up.
Yeah.
Yeah. So and that is kind of the day-to-day, right? Is it's holding you back in productivity. And we're expanding that idea of technical debt to what you just mentioned, like architecture, for instance, or technology choice. Now it becomes even more complex, I imagine, because when you're building on an old legacy platform, you of course need to deal with technical debt in many different ways. But how do you quantify what it would have gained if you were to resolve this a long time ago? Or how can you make a business case of resolving this structurally?
Yeah, I look at it as a sort of, I think what you're saying is, how do you bridge the gap between technical debt and how does that impact business value, and how do you know, how are you able to ask for investments to prioritize managing technical debt, right? It's sort of, how do you convince the business that this is important? In those lines, I think it is important to, what I've found, at least in my experience, these stats are good, but it's really important to turn that around to say, how does this impact the business in terms of feature development? You could show, oh, we're not like, listen, they're spending X amount of time on maintenance and not so much on feature development. Is it slowing your features that you want to deploy to the market? But there's also making it more accessible in terms of storytelling, having a compelling story using all of that data that you collect within, and I know our organizations collect a lot of metrics in terms of how their companies function, but being able to turn that into a story. I know there was a LinkedIn example of they said, oh, we decreased our technical debt, improved our processes, and our developers are now, don't quote me on this, something like 40% more productive. It's just like a simple, people tend to, those kind of leading with data, but a very simple, clear impact. I think that it's a difficult skill to have, but it is a powerful skill to be able to tell a story, provide a shared understanding on why this is important. But really, I think it is through storytelling.
Right.
And I think it helps to kind of outline the capabilities that will be unlocked if we go through that work and go through that effort. So to give an example, earlier in my career, I'd worked on a particular code base where it was supposed to be a very simple code base, but it was very, very old. And the point of it was that we wanted to spin up some database tables, spin up an API, just simple create, read, update, delete, simple operations, and then use that to save information about users. And the fact of the matter was, like, that code base was about, I think, 5 or 6 years old. Everyone that had written it had moved on, and so no one had any idea how it worked. And so for me to figure it out took so long, was so exhausting. When we deployed it, it was really flaky. And so I had to go to my non-technical stakeholders and say, hey, we're saying that we're a data-driven organization, as every organization does, but we don't have good data capabilities. So we need to kind of do this work, because this is going to enable us to robustly be able to store, process, handle our data, and that unlocks future features for us. And so by explaining kind of that future value and sort of to the point of storytelling, selling kind of the vision of what the capabilities will be going forward, that helps to also kind of align folks.
Hakan, how do we communicate this and bridge the gap between engineering and management or product leadership?
Well, I mean, we talked about quantitative analysis, but that is not the most important part. I think the most important part is that the financial metaphor helps communicate kind of in general the value of technical excellence, the value of proper engineering practices, the value of carefully evaluating technological choices, and so on. And executives, managers, business leaders understand the concept of debt, not necessarily debt with a strictly negative connotation, but also debt as a beneficial financial instrument. So just kind of understanding the metaphor and letting the technical leaders understand it, and executives, managers, business leaders already understand it, kind of helps us to bridge communication between the two communities. And once we start with the kind of financial metaphor, we can also extend it kind of, beyond just, main or basic technical debt, beyond principal and interest, to other financial strategies to deal with all sorts of technical decisions, like refinancing. Its software equivalent could be, for example, switching architectural strategies so that compounding effects are reduced. This is very similar, in terms of the financial metaphor, to refinancing. And there are also analogies for leveraging, amortization, and taking options for future opportunities, which in corporate finance is called real options, and so on. So the analogies of these concepts, the financial concepts, beyond just pure technical debt, exist in software development, and actually they hold quite accurately. And then the idea becomes even more useful in communicating, technical strategies, remedial strategies, using a vocabulary that focuses on the bottom line, and both technical leaders and managers understand it. So kind of, that's my perspective.
So from an engineering point of view, a different way to describe technical debt is deferred maintenance, I guess. And the metaphor you say, that works very well to communicate in different departments. That does beg the question, who owns technical debt in an organization? Is that the CFO
Well,
maybe?
it's-
Or
The question is like, the question is like, who is responsible for testing and development teams? The short answer is everyone. I think it's a question that involves kind of all stakeholders, and all stakeholders need to understand the vocabulary that they're using and kind of understand the implications of decision making, maybe on executive or manager level. But understanding of the consequences and understanding the metaphor is on everyone.
Yeah, I think there's software development is a team sport. It's not an individual, one individual software in large organizations cannot be creating impactful software, right? So when we look at it as a team sport, when you look at it through the software development lifecycle, you start off with from research to development, research to even finding documentation, finding the right AWS, and then finding the right AWS services to use. Like those things all cause delays in the time to market. And then there's the development, the design process. Is the architecture accurate? Is that, does that make sense from a scalability perspective? I'm just giving some examples. And then there's coding. Are we using secure coding practices? And then you go into deployment. Is it automated in terms of infrastructure as code? Is that, or are your developers and do you have a separate, ops team that's doing this? That also causes delay. And then you end up in production. You see, is this actually how's the user experience? So it's when you look at the value stream of a software development lifecycle, all of that. So it's a team sport, and all teams that touch that are part of that. And the second part of this is prioritization. Is a business prioritizing these things? And it goes back to your question of how do you connect the dots between, from a developer standpoint, developers know there's technical debt. That's never the problem. It's how do they communicate that to make sure that business understand the value of it and understand the value stream and prioritizing the right things. Yeah. So for me, I would look at it as to be very practical and pragmatic. To look at it as just starting very small and looking at taking a pilot project that has a high impact and high visibility, and getting your stakeholders engaged early on so they understand this. They feel that when I say stakeholders, business stakeholders, that they understand they're part of this, and collecting data and metrics it's not the specific data or metrics, it's a trend. Is there progress? How's the progress impacting other things? And then celebrating success as well. So that builds trust, that gains trust from the business side that, you're able to manage this, and here's how, and then they give you another project to invest in. So yeah, that's how I would look at it.
Yeah, I think there's two really good ways to look at that. One is sort of like the top-down perspective, and the other is the bottom-up perspective. So from the top-down perspective, I think it's Conway's law, or there's some sort of law where it basically says that your software architecture follows your organization's architecture. So from that point of view, the CEO or the C-suite or whoever is making the organizational level decisions, has a responsibility to make sure that the way they've created teams, created structures, and aligned people's incentives is, done it in the correct way, because that reflects in the way that software is developed from there. And that, of course, has implications on technical debt. From the bottom-up perspective, of course, each individual team, each individual developer has an obligation to make sure that there's good practices, good standards, pull request reviews, things that they're doing to make sure that on the day-to-day that good code hygiene is being maintained. So I think it's important to look at it from both perspectives and make sure that at the executive level and also at the individual developer level that folks are prioritizing this and thinking about the long-term implications of the software development lifecycle.
And that bottom-up perspective is interesting, leading into our next topic, which is frameworks, tools, AI. Right, so the audience clearly doesn't believe that AI will solve this problem. I didn't believe it either, just so you know. But so how can AI or modern tooling help speed up paying back technical debt?
Yeah.
Go ahead.
Yeah, it's pretty interesting. So I've seen differing things about the implications of AI on this topic of technical debt. So one article I read recently was saying that basically code churn is actually increasing as developers are using tools like GitHub Copilot and so on in their day-to-day workflows. And so code churn is basically the idea that when code is committed to the master branch that code is getting rewritten and revised more frequently. So that, I guess the implication of that would be there's sort of more technical debt being introduced in a way. On the other hand, there's some tools, for example, like if you guys have seen Sweet Agent, which is an agent that basically is now putting out pull requests on GitHub issues and autonomously solving GitHub issues. It's not perfect. I think it's getting it right in about like 12, 13% of cases, but the point being that there's active research done to actually create AI systems that are solving GitHub issues actively and autonomously. So there's kind of both perspectives. To the audience's point, I don't think it's snap the finger and everything is fixed, but it's an interesting and evolving field that I think we should all continue to keep our finger to the pulse of.
Yeah, and again, yeah, I can share more with that. This is not a plug for AWS because that's not this, but I have some access to data internally, and they publish this. So Amazon Q for Developers is used to be Code Whisperer. That's the service now. They did an internal test they converted 10,000 applications from Java 7 to, I forget which one, Java 12. Oh, sorry, I forget. It was 18, I think, with 5 developers in 2 days. And so they estimated what the before would be in terms of how much that would take to upgrade just that framework. And they saved about 10 person year time. So that's a very specific, it was a small scale study, but it was 10,000 applications. 5 developers were able to do it in 2 days. Because Amazon Q was able to have that code transformation, essentially transforms the code from a deprecated framework to a new framework. And of course, they had to do testing and all that, but that's pretty incredible in terms of the potential where AI can benefit developers in terms of code transformation for old frameworks. Even if you're a new developer going into a large organization that has legacy the system, let's use COBOL as an example, and the people that worked on it have left, and you've got a lack of documentation. There are AIs where those areas of making the life of a developer easier by being able to provide some insights into the architecture, being able to provide documentation that it can, otherwise you wouldn't have architecture records for these systems, and sort of understand the dependencies across systems. So those are things that there's a lot of potential where AI can benefit. The idea is that how do you make the life of a developer easier to what we call as undifferentiated work, where they're not spending time on undifferentiated work and they're spending time on the valuable stuff, which is coding features. Yeah.
Hakan?
Yeah, I mean, obviously, generative AI is making an impact in terms of how developers are working. And the Copilot for my students is basically replacing Google searches, Stack Overflow searches that they used to make, and they can even fix things automatically, have code explained to them. So as coding assistant and fixing and patching, AI is super useful. But the kind of AI that we kind of understand and use nowadays is AI based on models that are trained using historical data. And there's a danger there because historical data in especially software engineering is sometimes shaky. An example of historical data in SE would be the kind of rich data that we can extract from open source repositories and issue tracking systems like GitHub, Jira, and whatnot. The main problem with relying on that kind of data to give advice on best practices, if that is the aim of AI in helping developers make decisions about what to do next, about different things, who should we pick as the reviewer for this new feature that was committed, things of that sort. So the problem with that is historical data by definition represents average practice. It may not represent the state of the art, or it may even represent substandard practice if substandard practice is common in the industry. So you take that advice, apply it, and produce more data to train future models. You end up reinforcing that same advice further, that same suboptimal advice further. Ultimately, it becomes a self-fulfilling prophecy and results in full reversion to the mean effect in the industry. This is actually not specific to software engineering. It's discussed in general by this author, Kathy O'Neill's, in her book called Weapons of Math Destruction. So we need to be a little bit careful about that. And this is not just an opinion. We demonstrated this effect in recent research work. It was published in IEEE Software with the title Ground Truth Deficiencies in Software Engineering, subtitled When Codifying the Past Can Be Counterproductive. And with several case studies, we demonstrated that tools that were making software engineering recommendations were actually kind of suffering from that reversion to the mean effect. And we cannot improve state of the art by kind of blocking, by only relying on past practice as an example of perfect practice and blocking novelty and the push for improving practices. And we need also to combine historical data, perhaps with rule-based systems where the rules represent the accepted kind of standard of practice by industry leaders. So AI is great; it helps us in many aspects, but there are dangers in it in terms of its potential to block progress and improvement in the industry.
Are your students allowed to use AI?
Yes, they are. Yeah, I mean, I think educators have lost that battle a while ago. It is more severe in, I don't know, social studies and humanities because, in those domains, words are their currency. So kind of it's very problematic. In software development, I think it's less problematic because, our students were already using all sorts of online sources. And I specifically, in my full stack course, encourage use of Copilot. And so without it, you will basically have a productivity hit that is maybe 10x. So you might as well learn how to use it properly so that you don't have to, spin your wheels trying to solve a problem that Copilot can solve for you in seconds.
Mm-hmm. Got a few more questions, and then I want to hand it off to the audience for your questions. So if you have one, just be prepared. Kind of closing off this discussion, the main theme here is how can we boost value by managing technical debt? What would be kind of your final statement on this? If you need to give recommendations to this group.
I would say think about it hard, think about it early, engage your technical counterparts, and ask them to kind of come up with a couple of scenarios. So in the short, medium, long term, say like 3, 6, 12 months, if we do deal with this, what happens? If we don't deal with this, what happens? If we take some sort of a medium approach where we kind of deal with it, what happens? And I think that encouraging your developers to kind of articulate that helps to give a better perspective. And then from there, the key stakeholders can come up with a decision of, hey, is this worth it to address at this time or not?
Yeah, and I would look at it from a holistic standpoint of the developer experience, as we were talking about the entire software development lifecycle. Looking at it from the beginning of research, when they have to start looking at a feature that they're developing, how much, it's not time, it's more undifferentiated work that they're spending time on, and then what are they doing in terms of how do they prioritize it, and then the coding. So I would look at it from that whole perspective. But the most important thing for technical debt management that I've found, at least from my experience, is being able to provide really fast feedback to developers. Is that baked into the process where if a developer is writing a small code base on their IDE, do they get fast enough feedback that it doesn't need to go into a development environment for them to realize that they broke something? Are they able to get something within their IDE to say this doesn't break other areas? So they get really fast feedback, so you're stopping the technical debt where it begins. And so I think looking at that, it's called micro feedback loops, and also doing very small chunks of code, and are they able to push how, frequency of deployment to production, right? So or even code commits to merge to a main branch, how frequently are they able to do it? So they're able to get the feedback back. So if I had to pick one thing, I would say how the feedback loop for a developer, how fast is it? And start from the beginning of the whole software development lifecycle and look at it holistically.
For me, I think the first thing is to make sure that everybody understands the financial metaphor, not just superficially or in an informal or intuitive manner, but truly understand it. And then make sure everyone understands the desirable and intentional forms of TD that can be strategically or tactically, and also the undesirable, unintentional kinds that can make a software project die a death by 1,000 cuts. And I think it starts there. And then once the people have the vocabulary, understand the kind of the analogies, then they can actually bring up and discuss the related issues more easily.
All right. Any questions? I don't know if I can do this. You'll tell me, right?
Thank you. Fantastic panel. Thank you guys so much. End of life versus technical debt, right? Something hits end of life because it's no longer supported by a vendor, or the software needs to be patched, right? Technical debt is far more extensive a topic than that. Do you typically try to assign technical debt dollar values to each application in order to have that application owner talk with their business sponsor so that it's not a philosophical, across the board technical debt is, blah, versus your app, XYZ, has dollar amount this costing us versus its gain, and therefore we have to address it?
Yeah, I could share an example. That's a really good question. So with end of life, when I started this, I talked about some metrics. There's no one size fits all. So you have to look at business criticality. But if it is a business criticality, then I'll just give some examples of practical. If you're looking at end of life, then you could quantify, are you able to integrate with other systems within your own organization or with externally? The second thing, and then say, how much is that going to cost for developers to have to now not be able to integrate this or deploy features? There's different things that you can look at. Older systems don't have the ability for integration. The second, not all of them, but some of them. Second would also be, I would look at also talent. Your best developers are not going to want to work on outdated systems. They're going to demand, newer systems. They were going to want to work on interesting things. So you have to, and for developer sentiment, usually surveys, it's an underrated thing, I think, understanding developer sentiment through surveys to say, hey, 70% of our developers are frustrated working on this, and this is, there's a whole study on developer experience that's happening around how to quantify that and tie it to business outcomes. And then others also, developer retention. But yeah, I think things you could look at it based on your specific organization. How does end of life impact all these other areas and the developers as well, and then quantify that. So I hope that helps.
Yeah, I would say this might be my bias a little bit, just because for me, my specific development experience right now is very focused on consumer. But I guess, again, coming back to how you quantify and quantize the actual cost, two ways to look at it. One is sort of software development cost. How much would it take to continue maintaining this existing infrastructure going forward? And that can be more applicable in certain cases where you have a very stable software infrastructure that's not going to change very much in the next year, next couple of years. The other way to look at it, and this is really true in consumers, it's very, very fast moving, and you have to be very, very adaptive to rapidly changing market circumstances. So the other way to look at it is to say, hey, okay, this is preventing us from capturing a certain market opportunity. So we really need to end of life this right now to go on to the next thing. So even more recently, there was some frameworks that I ran into that were preventing us from moving on to the latest front-end infrastructure and that had implications on things like the critical metrics and stuff that were valuable to our users. And so it became important for us to end of life certain software so that we could actually deliver the things that our users wanted. So that's another perspective that I think is valuable for folks to keep in mind. But it very much depends on your organization's software context.
Okay.
So maybe I can add something. So in the late 2000s, Steve McConnell wrote an article about technical debt, classifying it into its different forms, and then talking about its use in different project phases. And in that article, he also talks about how to manage technical debt when the project is close to being retired, so end of life, TD decisions. And he says, logically, that optimal decisions favor, in those circumstances, taking on technical debt or avoid paying it back, because the effort of avoiding it will not be amortized. As I said before, financial debt never disappears. It's always there, even if the project dies. But technical debt actually disappears once the project is retired. So then, taking on technical debt is a strategic decision with end-of-life technical debt management strategies.
Yeah, to piggyback off the same question about quantifying, what are like some tools or methods that you guys use to kind of like generate some technical debt score similar to like code coverage or security assessment risk? Yeah.
Just like a rule of thumb for me as a developer who's like really kind of hands-on keyboard, I have like kind of an intuition as to how long it takes to do like basic tasks like set up a database, spin up an API. There's certain like these sort of building block tasks for like full stack and application development. And so I know how long it takes for me to do that with, if I'm just, starting a brand new project and just doing that from scratch with, the latest and greatest open source technologies, whatever that is, like whether it's spinning up a Postgres database or setting up APIs with like, Node.js or Express or Flask or whatever framework you prefer. And so when I'm going through that same process, those basic tasks inside of an organization, usually I find it takes substantially longer. And it's useful to think about why that is and what's like the multiplier there. So if it's like, okay, well, I know this would have taken me an hour to do in just like my personal project, but this took me 3 days to do inside of my organization, that's when, some alarm bells start ringing, and you can start kind of thinking about what's like this multiplier. And that's sort of like a rough estimate of your tech debt. So that's more of like a rule of thumb personally. It's not necessarily super empirical, but I find it to be very useful.
Yeah, and I think another area around technical, there's lots of services that you can look at code complexity and duplication and see how is that increasing or decreasing as you're building. But there's also other metrics, like DORA metrics is a good example of how they do, lead to, that ties into what they've done really well, is tie those technical debt metrics to business outcomes. So you could look into that, and the idea is like doing that, sort of collecting those metrics over time and showing sort of that to both, well, it's that fast feedback loop again, being able to quickly show, hey, this has immediately impacted what you've done in the immediate, what your team has done. It's increased code complexity or it's reducing. So I think there's ways to look at, there's lots of standardized metrics that you can implement and then collect that over time, and then tying that back to business outcomes is really important.
So to add to that, for quantification, you need data, whether it's data that is based on personal experience, kind of informal, or data that the organization collects. I don't know, if you want to use code coverage, for example, you need data to be able to reliably use it. That explains the relationship between poor coverage and incidence of bugs. If you're using complexity, then you need a similar data that exploits the relationship between high complexity and incidence of bugs. And if you have that, then you can convert those metrics into their bottom line implications. And what kind of data you need, it depends on the decision that you need to make. I mean, different decisions in different contexts can leverage different kinds of data. In fact, I teach a course on software economics, and it's based on case studies for different technical and managerial decisions that happens in software development. And each one of them uses different data sources that come from either kind of organizational benchmarks, open source repositories, other external sources, and plus a bunch of assumptions that the decision maker makes so that the data is grounded on those assumptions, because any quantitative analysis is really conditional on your beliefs and assumptions that you make, like your belief that actually code complexity has something to do with, incidence of bugs. And then you can actually build on that.
We have time for one last question, and then lunch is served.
Very good. Thank you very much for this informative panel. My question, sticking on the point around the cost, I want to talk about particularly not the quantifiable cost, but in highly regulated industries like banking. How do you guys consider a potential reputational or franchise risk as it relates to going live with, technical release that might have an impact today? If you look at what happened with the New York Stock Exchange just 2 days ago, but it could have an impact 3, 6 months, or a year from now that could talk about millions, even billions of dollars, and leads to high fines.
Yeah, I'll take back to the study that I mentioned, where they did quantify. For example, there was a data breach typically would cost, trust is one of that, but also they could quantify it to say it's on average 4.5 million to a large organization. So there are ways to tie it back to quantifiable metrics, but also I think what you're saying is the qualitative stuff around losing customers' trust is really important. And how would you quantify that, right? You could quantify that to say, are your customers switching to someone else? If you're in a bank, are you losing? And sometimes it could be a proxy metric. So it's important to look at it, what type of metrics you're using, but you have to look at it through like a holistic multi-dimensional perspective. The financial aspect, economic aspect is always helpful to quantify certain things and easy to put on paper, but all these other things that you're mentioning is a good point. And even developer productivity, how do you, measure that? It's very hard to measure developer productivity. So surveys and qualitative analysis and sentiment analysis is really important to make sure you're having a holistic picture. But it doesn't really directly answer your question, but there are ways of making sure that that's included in the story you're sharing to your stakeholders.
Yeah, I think
So,
sorry.
sorry.
Go ahead. Go for it.
Okay, so to add to Vidya's, people think that reputational risk is maybe intangible, but it's actually not that intangible. Reputation damaging events have consequences, and those consequences will eventually have bottom line implications. And are those implications measurable? And sometimes with the data that is available, they are. Insurance companies actually price reputational risk all the time. They rely on things like, the relationship between reputation damaging incidents and shareholder value, like the drop in stock prices if it's a public company. So there are ways, the presence of suitable data to even kind of quantify things that at first or intuitively sound to us intangible in terms of its financial implications.
Yeah, and I would say one thing to pay very close attention to with this in particular is how much back and forth there is between the actual development cycle and then whatever like QA architecture you have around you. So that QA architecture, quote unquote, it obviously is going to differ in terms of the specifics from organization to organization. But that first line of defense is generally going to be, your CI/CD pipeline, and that can go all the way to having like a manual QA team. I've worked in code bases where there's been a ton of technical debt. So sometimes you make a change in one place and it leads to very unintuitive changes in other places. So you thought you fixed something or made something look great here, and then another part of the screen, if you're working on UI, is all, looking all crazy. And so in those experiences, I've noticed that, there's a lot of back and forth between our test suite and our CI/CD pipeline. There's a lot of back and forth between myself as a developer and our QA team. And that's usually like a red flag if you're having to go back and forth, if a lot of like unintuitive bugs and issues are coming up, that you kind of have a deeper problem that you might want to pay attention to. And that, and if that's the case, then you can imagine how that kind of becomes risky for the organization if developers don't even have confidence that if they make a change in one place, it's not going to lead to cascading issues.
All right. And that kind of sums up our panel discussion here. So round of applause for our panelists there. Thank you so much, Prithvi, Vijay, and Hakan.